So this question was like kind of like confusing or kind of like interesting. So in this question, you have a polygon enclosed by the solid lines in the figure that consists of 4 congruent squares joined edge to edge. So we're given 1 more congruent squares attached to an edge at one of the 9 positions indicated. We want to know how many of the 9 resulting polygons can be folded to form a cube with 1 face missing. So this is like kind of like 3D stuff. So you have to like make sure you have a good idea of what the question is asking. So just as an example, like for example, 4 would work, right? Because if you like, let's consider the square 4. If we were to like imagine this, right? If we were to like fold this polygon thingy, right? Pretend like this blue square is like the base of the square, is like the bottom face of the square, right? So like let's draw that here. And let's imagine this green face, this green square, you can kind of like fold it up, right? So like you can kind of like fold it up. So like you fold it upward, like, and then you can look at this, let's say this like this yellow face here. You can imagine folding that like kind of like to the side, right? So like, that would represent like this yellow face here. And then if you were to like imagine like, you know, let's say you have like, this black square here. And if you were to fold that, you can imagine like it kind of folding all the way up to here. Like you kind of have to use your imagination skills that the black square would fold all the way up there to the top face of the cube. And then if you were to imagine it, like the red face would fold all the way over here. Like if you were to like fold it like all the way like that, right? So that tells us that like square 4 works out because like, you know, we have 5 faces of the cube. The only face that is missing is like kind of like, it's hard to indicate. It's like, it's kind of like this face in the back, right? This face, that red face there is missing once we fold all of those 5 squares together. So that tells us like square 4 works. So you can kind of like use this idea. And the idea is you just kind of have to check them one by one. Like there's no easy way to really do this. So basically like, let's look at like square 1, for example. If you looked at square 1, like, and you imagine folding this, like the reason this won't work is because like, again, like the blue square is going to stay at the base, right? Stay at the bottom of the cube. Then you have the green square. If you fold it upward, you're going to get like this. Like you fold it upward. Then you fold the yellow square. When you fold the yellow square, you're going to get like this face. But then notice that the black square and the red square are going to coincide, like, right? It's like the red square wants this top face, but the black square also wants this top face. So like you can't have 2 like square faces like matching up on one face of the cube. Like that doesn't work because yeah, like that doesn't meet the problem conditions. That tells us that like square 1 doesn't work. So we can kind of like repeat this process, right? So now let's take a look at like square 2. If we were to like fold square 2, like this also doesn't really work because like if you just imagine it, right? If you fold it again, so we're gonna have a blue base, and then we fold the green face up like that. The problem is when you fold the green face up, like the red face is also gonna get folded up, like because they're like joined together by this line. So like when the green face folds up, the red face is also gonna fold up. So as we had before, the yellow face is going to fold over here. But then like, and the black face is going to come to the top. But then that creates a problem because the red face here, like it has nowhere to go. Like if you're to fold it like this way, then it's going to overlap with the yellow face, which doesn't work out. And you can't fold it like this way either. Then it overlap with the green face. So it doesn't work out like that either. It's like square 2 doesn't work either. It's like that doesn't work. So now we can test like face like 3, right? So suppose we have this face here. Then we can like, again, we have like our blue base that looks something like this. The green face is going to fold up. The yellow face is going to come over here to the side. And the black face is going to fold upward, like to the top face of the cube. But then like, the problem is like, again, like notice that like the black square and the red square are like kind of joined together, right? They're kind of like, you can kind of think of they're like glued together by this red line here. So by folding the black square up to the top face, you're also like folding like the red square up here. And once you fold the red square up there, like there's no place for the red square to go. You can't like fold it this way. You can't fold it like this way, like because then they'll already overlap with squares already there. So like square 3 also doesn't work. So that tells us squares 1, 2, and 3 don't work. We already talked about that square 4 worked, right? And it turns out like squares 5, 6, 7, 8, and 9, like they all work. But like I'll just like go over like a few more just to like make it more clear, right? So like we found that squares 1, 2, 3 don't work, but square 4 does work. So if you have like square 5, again, if we treat this blue face here as our like bottom face of the cube, the green face goes up, the yellow face like comes over here, the black face goes to the top. And then basically we can kind of like imagine that like remember, you can think of like the red square and the black square, they're kind of like glued together by this red line there. So when you fold the black square up to the top face of the cube, the red square is gonna like fold over here, right? This line, this red like glue line kind of represents like this line there. But like in this case, you can fold this like red square down because now that like completes this, there's no like face there yet, and that would satisfy the problem conditions. So like in that case, square 5 would also work. So like you don't have to like draw this out. You should like when you get more practice with like 3D visualization, right? With like nets of a cube and like folding them together, it should be like pretty intuitive to think about. It should go by pretty fast. So you can check that squares 4, 5, 6, 7, 8, and 9. Turns out they all work. And it turns out squares 1, 2, and 3 don't work. So if you're to count them all up, you would get like 6 total squares. All the squares from 4 through 9 work. Like if you just try them one by one. Yeah, so that means the answer would be like E.